Okay, this will be a relatively short video where we learn how to classify monosaccharides. So the simplest carbohydrates are the monosaccharides that consist of a single polyhydroxyaldehyde or ketone unit. Glucose and ribulose that are shown here are examples of monosaccharides. And monosaccharides are further classified according to the number of carbon atoms that they contain. So first of all, if we have an aldehyde group, we call that an aldose. So whenever we have an aldehyde group at the top, we call that an aldose. And if we have a ketone group towards the top of our molecule, we're going to call that a ketose. So we have aldoses and ketoses. And then we also classify according to the number of carbons. So if we have 3 carbons, it's a triose. So 3 carbons is a triose. If we have 4, it's a tetrose. 5 is a pentose. 6 is a hexose. And so if we look at glucose, glucose has a total of 6 carbons and it's an aldose. So it would be an aldohexose. If we have ribulose, it's a ketose, but it has 5 carbons total. So it would be a ketopentose. So if we look at erythrulose, which is a natural sugar present in red berries like raspberries, we're going to classify erythrulose by combining the aldehyde ketone designation with the terminology indicating the number of carbon atoms as just described. Well, we can see right away that since our carbonyl is flanked by 2 carbons, that this is a ketose. Okay. And then if we count the total number of carbons, we have 1, 2, 3, 4. So this would be a ketotetrose. So we'll put down here ketotetrose. And so we have the family of D-aldoses shown here. We go from glyceraldehyde, which is the first one, okay, and our hydroxy is pointing to the right-hand side, and so it's a D sugar, right? D-aldoses. Then we go to erythrose, and you see the hydroxy is pointing on the right-hand side of both of these. So these are both D-erythrose and threose, excuse me, but these are both tetroses. So we go from glyceraldehyde, which is a triose, to we go to the tetroses, and there's 2 of them, erythrose and threose. You don't have to memorize these names, by the way. Then if we go to the aldopentoses, again, you can see these are all the D sugars, right? And we have ribose, arabinose, xylose, and lysose. And again, you don't have to memorize these names. But if you think about the number of chiral carbons that we have here, right? If you just pick this pentose, 1, 2, 3, you take 2 to the power of 3, so that's 2 times 2, which is 4 times 2, which gives us 8. But I'm only showing 4 here. So what are the other 4? Well, the other 4 would be their enantiomers, which would be L sugars. And I told you we're not really concerned with L sugars all that much in this class because those are unnatural. The same thing here. If you look at all the stereoisomers of glucose, you can see glucose shown here, which has 1, 2, 3, 4 chiral centers. So we have 2 to the power of 4, which is equal to 16, but I'm only showing 8 here. Well, 16 divided by 2 gives me 8. So besides D-allose, D-altrose, D-glucose, D-mannose, D-gulose, D-idose, D-galactose, and D-talose, I would also have the L isomer of all of these, but again, those are unnatural sugars, and so we're not really concerned with those in this class. So you need to know what a triose, tetrose, pentose, and aldose is. I always think that it's a good idea to have the structure of D-glyceraldehyde memorized. Your chemistry students, you should have a bit of an idea. And I don't ask my students to memorize the structure of glucose, but it's one of those things that if you're going to move on in biochemistry, it's never a bad idea to memorize the structure of D-glucose. D-glucose is the most abundant monosaccharide on Earth, and there's good reasons for that, which we don't go into in this course. But there you go, the family of D-aldoses.